Greetings, this is Chemistry with Nav. In this short video I want to show you why benzene is less reactive than expected, in particular that it does not react directly with bromine as an alkene does. In an alkene we have a pi bond which is made up of the sideways overlap of p orbitals. So we have two delocalized electrons in that region. And because it's quite a small volume, then you've actually got quite a high electron density, and as a result you can induce a dipole in a bromine molecule, and in turn you end up with an electrophilic addition reaction. Now if we look at the Kekule model, where we expect to see three double bonds around the benzene structure, then we should have something that's really quite similar. Because we have these three double bonds, we have these three regions of high electron density, but in fact we know that benzene doesn't actually react with bromine. So if it doesn't react with bromine directly, that means that it can't induce that dipole, which means that the electron density must be more spread out. So that's where the delocalized model comes in. So we have the same p orbitals, but this time the electron density is actually spread across the whole of that ring, both above and below, same as with the pi bond in the alkene. And because that same 6 delocalized electrons occupy that space, you can see that on the right hand side the delocalized electrons are moving in a much larger environment, and therefore we have a lower electron density, therefore we can't induce the dipole in bromine. This also leads on to the idea of stability, and we look at stability in benzene to do with the enthalpy of hydrogenation. Now, the product of the hydrogenation of benzene, whether it's the Kekule structure or the delocalized structure, is always going to be cyclohexane, because we're starting with C6H6, we're adding hydrogen, we're going to end up with C6H12. Now, if it was the Kekule structure, we would expect the enthalpy of hydrogenation to be 3 times that of cyclohexene, which effectively is benzene plus 3H2, and the delta H for that would be 3 times minus 120, which is minus 360 kilojoules per mole. But then when we actually hydrogenate benzene, the value that is achieved is minus 208 kilojoules per mole. And that is because it is the delocalized structure. Same addition of 3 hydrogens, but now it's only 208 kilojoules away from cyclohexane. So in other words, it is much lower in energy, it's more stable, it's closer to that ground state. And that's where we can see that benzene is more stable than the Kekule structure.